Anmol, this E assignment is getting on my nerves.
Same here, man.
Oh no, yaar.
This will work.
Anmol, why do you use such kind of lamps? These are so old-fashioned.
What do you mean by old-fashioned? I got it for 150 rupees last week.
Haven't you heard about LED lamps? They give the same brightness using lesser power.
LED lamps?
LEDs are light-emitting diodes.
A light-emitting diode LED is a semiconductor light source. LEDs are used as indicator lamps in many devices and are increasingly used for other lighting. When a light-emitting diode is forward biased, that is, switched on, electrons are able to recombine with electron holes within the device, releasing energy in form of photons. This effect is called electroluminescence, and the color of light corresponding to the energy of the photon is determined by the energy gap of the semiconductor. The LED consists of a chip of semiconducting material doped with impurities to create a PN junction. As in other diodes, current flows easily from P side or anode to N side or cathode, but not in the reverse direction. Charge carriers, electrons and holes flow into the junction from electrodes with different voltages. When an electron meets a hole, it falls into a lower energy level and releases energy in form of a photon.
And that's all about LED lamps.
Heard that screen noise? I heard the guard saying there's a problem with the main circuit. And what's wrong with the electricity?
Hi Anmol, I knew that. Let's check out.
Fast! This one?
Yeah, this one.
Oh my god! Oh my god! Oh my god! It's a Zener breakdown. We need to call the electrician.
Seriously? What is it?
Zener. Zener effect. The Zener effect is a type of electrical breakdown in a reverse biased PN diode, in which the electrical field across the diode breaks some of the covalent bonds of the semiconductor atoms, leading to a large number of free minority carriers which suddenly reverse the current. Zener breakdown is employed in a Zener diode. Mechanism. Under a high reverse voltage, the PN junction's depletion region expands, leading to a high strength electrical field across the junction. The electrical field acts to break covalent bonds of the semiconductor atoms, which liberate a large number of free minority carriers. This suddenly increases the reverse current and gives rise to the high slope resistance of the Zener diode.
Yeah, exactly.
Hey, heard that sound? Sounds good. So let's find out. No. I've got my e-project to do. Come on, yaar.
Oh, good, you're here. Where are the rest of the guys?
E-project.
Oh, even I have that. Oh, I came up with this new riff. You want to listen to it?
Sure.
It's not sounding right. Oh, wait, I forgot to turn on my distortion pedal.
That's good. That's actually good. But I've got just one question. What's that?
That's a distortion pedal.
Guitar distortion pedal. Guitar pedals are electronic devices that alter how a musical instrument sounds. Some pedals subtly color a sound while others transform it dramatically. All the pedals are based on an operational amplifier or transistor based design, so it is important to understand why they are so commonly used. Transistors and operational amplifiers both allow a varying voltage that is applied to one of its three legs to control a proportionally larger one between the other two. That is the basic principle behind their amplification capabilities. Working of guitar pedals. Increasing the resistance of R2 will increase the voltage gain of the circuit. Guitarists can use this effect on its own. It would provide a level boost that when switched into the player's signal chain, would drive the amplifier further into saturation. Heavy metal guitarists could use this effect when they play a solo in the middle of a song, as it will give them the extra cut that they need to be heard above the rest of the band. How do diodes help in this? Diodes are electric components that resist current in one direction only. All diodes have a forward voltage threshold, at which point the diode begins to lose its resistance and will therefore gradually allow a voltage to fluctuate between positive and negative. It is the diode's transition into this resistance drop that determines the type of distortion it produces. As each diode begins to lose its resistance, it will introduce a harmonics into the signal, which produces distortion.
It's so dark, man. I can't even see the stairs.
What happened, Abdul? How did the lights turn on? Seems like you're here for the first time you've light, huh?
But yeah, he's supposed to be turned on at night.
No, dude. These are light sensors which work on the principle of diode. Okay?
Sensors. Light sensors use photodiode to convert light energy to electrical energy. A photodiode is a type of photodetector capable of converting light energy into either current or voltage, depending upon the mode of operation. A photodiode is a PN junction or PIN structure. When a photon of sufficient energy strikes the diode, it excites an electron, thereby creating a free electron and a positively charged electron hole.
Has anyone done the E assignment? E assignment? E assignment?
Hey Nanda, have you done your E assignment? Have you done your E assignment?
E assignment?
Yes,
E assignment? No!
And why is your phone not charged since morning? It's dead.
My charger is not working.
Charger? Charger is not working? But why haven't you done your E assignment?
Because my charger is not working.
Charge is not working?
But why so?
Because it uses diode. A battery needs DC current for charging, but our household electricity is AC current. So we need a system which would convert AC current to DC current. A full wave rectifier converts the whole of the input waveform to one of constant polarity at its output. Full wave rectification converts both polarities of input waveform to DC current and yields a higher mean output voltage. 2 diodes and a center tap transformer or 4 diodes in a bridge configuration and any AC source, including transformer without center tap, are needed.
And that's all about diodes and its applications.
That's how diodes are used in our everyday lives.
We hope you enjoyed watching this movie.
And we really enjoyed making this movie.
Yeah, sure. Nanda!